Today, we bring you an exclusive look at Desert Mountain Energy, a company on the cutting edge of helium and hydrogen exploration. In this insightful interview, CEO Robert Rolfing discusses the breakthroughs, the challenges, and the timeline for moving from research to real revenue. For investors seeking the next opportunity in critical resources and clean energy innovation, this conversation is one you won't want to miss. And now, here's your host, Ellis Martin.
Rob, you've got a storied background, a lot of it here in New Mexico.
My dad worked on the Manhattan Project, and he had spent a lot of time at Los Alamos and at Trinity. That's where it really starts. And growing up, my first grade teacher was a nuclear physicist. I've had a love of science my entire life, and math, probably odd that somebody really loves math. But that's the way it worked out. And so how that has transformed over the years, being around math and science, and then also into geology. This state has so much unique geology, and it was studied. You go back and you look in the mid-40s, and even much earlier, prior to statehood, this state was searched for minerals. There's so many natural resources here in all types. And then you have the most important natural resource. You have the people who live here.
Certainly, the people that live here create the culture of the state, and it's very unique like nowhere else in the world.
The friendliness of the people that we have found working in Roswell, and even when I was doing just base geology between Arizona and here, and just traipsing around the countryside looking at, trying to confirm what other people have studied over many years. And when you see that, you're trying to confirm, or in my mind, the science in me, you get into approve or disprove a hypothesis. And then from that, I develop my own hypotheses. And a good scientist, you tend to throw out a lot along the way.
You mentioned Los Alamos. We've been friends for about 5 years now, and one of your mentors, I understand, was the king of isotopes, Edward Teller.
It is. My dad, he had two friends, and I remember this as a 5-year-old kid meeting a couple of my dad's friends, and one of them used to always bring me a silver dollar, a dime, and either a nickel or pennies, and that was Edward Teller. And I still have every silver dollar the man brought me. The dimes were always to put in an offering plate, and the pennies or a nickel, that could be for candy. And the way he did part of that was he took out the old fountain pen and he would put ET on it. So it's an interesting way how different people in my life over time have taught me so many aspects. But to me, that's always one thing about him that he had. Why me? Why try to teach just some little kid who obviously was just interested in money for candy? But it's, how do you transport that to today? And what do we as adults now try to find a way to give back and try to maybe spark the light bulb, get the light? When I've done lectures at universities anymore, most of the students, they sit there, and I freely admit I probably bores half of them to tears. They're only taking it because they have to. It's a required class. And you sit there, and when you see them put down the cell phones, and you actually see them looking at you, and you know you are making a connection. You see a light bulb come on. That's fun because you know you're actually, for a moment, you hopefully, in whatever aspect of their lives, but you hope that the spark is lighting a fire to them to do something. I want to see it in science, obviously, but just to be meaningful with their life. We all have a gift, and we have to find what that gift is.
What drives you? Certainly, you don't need to work anymore. You can retire if you want to. What has driven you all these years to work? You're not stopping. You're inspiring others that you work with, people that you meet every day with that philosophy.
Perhaps a lack of any good common sense. I love to learn. And that's one thing that when I'm sitting at home, I may have the TV on and the volume's down. And I'll be sitting, if it's something I want to watch, then I'll turn up the volume. Otherwise, I have the iPad or the phone in front of me, and it's probably as a white paper or what a lot of folks would just roll their eyes on, and it's very boring. Or it's someone else's study or a paper that they put together about specifics. Lately, it would be more than likely, it will have to do with xenon, all of the noble gases, and how are they actually formed. It's not just necessarily cosmic and atmospheric. I had a hypothesis, and we proved it up in Arizona, and we think when we drill new wells north of Roswell, we'll be able to prove that up further. But it's like everyone has their own idea on how something is formed. To me, I can chase rabbits down holes in some time. I'm just trying to get my mind wrapped around specific things like in north of Roswell. It's one of the few places in the world where you have the heavier isotopes, and you have xenon 130 to 136. You actually have krypton, not kryptonite, Krypton 84. They all have a specific use. Krypton has a use of not only for in between glass panes for insulation, but also krypton has to do some of the most cutting edge surgeries for where you have robotic surgery. They use krypton lasers. It emits a light pale blue glow, but yet it can also be used for ion impulse engines for space. There's so many different aspects of what we're working on with not just helium-4, but helium-3. What can it be used for? And it's fun to try to understand where you should be able to find it and then go and look for it.
You found it in Roswell, and it's pretty rare. Therefore, it's very expensive. Is your knowledge of the oil and gas industry and gases, as you say, which surpasses mine and probably most people watching, does it just point you like a dowser to parts of the planet where you can find something that's worth propagating and potentially doing a deal with for the future?
It's a mix of trying to think outside the box of where and how things can be formed. If you have uranium and thorium and lithium, specifically it's lithium-6, beryllium-7, and how they all interact. And you have to have enough of these materials naturally occurring, and you have to have them all in right together. They can't be separated because it gets into beta particles and how far they don't penetrate, gamma particles and neutrons and the exchange of neutrons. Again, I say I tend to make people's eyes glass over when I can start talking about that. To me, it's like, how do you exactly figure out how did it occur, not just cosmically, and it's contained within the Earth's crust because we have hydrogen at the core, we have a hot molten core, so we have uranium, thorium, everything generating different things. But what we have found is where it's being generated, slightly subsurface, not being formed in the mantle or the crust. Then you have to get into where the normal oil and gas ideology is thinking. You have to find a trapping mechanism for it. Where you're dealing with the absolute, in the case of hydrogen and helium, you're dealing with the two smallest molecules on the planet. Sometimes people ask, how small is small? And I'll have a whiteboard behind me and I pull out a 1 millimeter black pen and I'll put a dot in the middle. Then I'll just do an arbitrary 8.5 inch jagged oval around that dot in the middle. To again say, if you could increase a helium atom to the point where you could see it 1 millimeter, and if you had a pore space of 10%, and that's equivalent to what the same thing is, I like to ask, is it going to be this carbon molecule or is it going to be this helium molecules that's going to move through this pore space? How many can you store in this?
These gases are not really easy to transport because they're so small. So the end users have to be proximal to the supply.
And that's one thing about New Mexico. We're not worried about having to turn the helium-3 or helium-4 into a liquid. We can just do it and clean it up to a 99.99995% and transport in gaseous state. Where's it going to go? White Sands Missile Base, Sandia National Lab, or Los Alamos? Or in the case of when you have AI labs and the high end, when they're stacking 72 hard drives together now, that's the current. They're looking to go to 256, but right now it's 72 hard drives, and they use liquid helium to cool those. Plus, you can spin them faster. You end up getting 10 to the fourth power more ability of computing capacity out of it. Gets into quantum. And then the other aspect, it requires 38% less power.
You tossed the word quantum out there, and it's in the lingo of many people right now, and I think it's used as a way to sound important. Not that you're doing that, but it's a way to show some sort of intelligence with quantum technology, quantum computing, quantum entanglement. So I'm interested, but yet I don't believe half of what I'm hearing. I believe you. So I want to know what the word quantum means to you.
To me, it's going to see how much faster you can run data. And quantum entanglements. If a mother has a child and she is close to that child, that's very near. That child can be a world away, and yet she is still tied to that child. That's a type of quantum entanglement. That is an entanglement that goes on. Now, what it gets into more than that, they will still react. They're coming apart, and they can still react in relationship to each other, even though they are no longer directly in each other's immediate. You can still be far out and away.
How does quantum entanglement, as you described it, work in the science of these gases that you're dealing with in Roswell and the AI Center? Let's put that together.
To make the AI centers function to their optimum, you're dealing with power generation, power storage, energy. Energy is always just stored in one form or fashion, whether it be in a hydrocarbon or it's water or the sun. It's all energy. And how do you store it? How do you deal with that? There is an initiative, and the government announced it, to make a joint directed energy cooperative force. And it came out through DIBC, or Defense Industrial Base Consortium. And like, we were invited to join this JDEC. There will be a lot of companies in New Mexico who I'm sure were given that invite. And what it opens up is for small companies. There's so many people out there right now who have been, they're probably mid-40s going into early 50. They came out of college or they came out of school, and they've worked in a job for 20 plus years. So now their time in working, the time in service, and their age adds up to more than 59 and a half. So these people, a lot of cases, they qualify for a retirement. Now they feel like they've been pigeonholed, and this energy is existing with them. How do you take advantage of that? They look to change to something where you feel like you're actually accomplishing something. You're not sitting in one little spot. It gets back to your question, like, for what do I see myself doing? I have fun. There's parts of running a public corporation that are not fun. They're required. And there's other people who just thrive on doing that. Me, I love creating, thinking outside the box, and actually going after all the extremely hard to find elements and how you can use them within a data center. A lot of that aspect is beyond me. I read through it, I have a clue, but I'm just one step above clueless on part of that.
Yeah, but that cluelessness is just a mirage, because you're in the right place at the right time. You secured the wells in the Roswell area, in the West Pecos area, and the data center was after the fact. How do you know where to drill?
If you look back again during the Manhattan Project, there were studies done. There were scientists running around the U.S. and everywhere in the world, but they were looking for, between the U.S. and Canada, for secure supplies of specific elements. There's a lot of studies that have been done, and specifically how the Permian Basin and the Delaware Basin, that's geographically in West Texas and coming up, and they're known more for oil, but there is gas. And then you get into the northwest portion of the Delaware Basin, which is the northern edge, is Roswell. Just north of that is where we have the wells in the Pecos field. How does Xenon 130 to 136 and Helium-4, Helium-3, how does it show up there? How can it be transported? Where is it exactly? Was it cosmic, or is it being generated in the mantle? I think it really comes down to more of those studies that were done between then and the mid-60s and the 70s, and even into the 90s. There have been a lot of studies, and you get into all hypotheses. Is it cosmic drive? Is it come from the breakdown of uranium, thorium, and lithium in direct contact with each other, and specific types of minerals and rocks? I think it's a combination, depending on, when you look at the area north of Roswell and where we have our leases, this is very site-specific. It's like where I look in Arizona, very site-specific. You have to have everything correct in the basement or in the earth itself, in the mantle and crust, to be able to come up in microscopic amounts. Now it gets back to, what's a trapping mechanism for the two smallest molecules, hydrogen and helium? What can constrain that? Nothing will constrain it. There's been tests done, and for fun, I did this at the University of Oklahoma. We did a test where we put Helium-4 in a sealed glass container, and 1 year later, 42% was gone. And that is escaping through glass. That's not under any great pressure. That's just atmospheric, what we breathe out, 14 point some odd pounds per square inch. It's just, that's how small it is. And like Helium-3 is used primarily for everyone who's gone through the airport. You go put your arms up for the backscatter machine when that came into being, and then also at port of entries. Every port of entry, you have, people think it's X-ray. It's not really that, but you're looking at a scatter. You're trying to look inside vehicles and see what's on the inside, and also to ensure that you don't have dirty nuclear materials coming in that could be weaponized. The other thing you can use with it is Helium-3 can be used in a newer type of reactor. And if you really get down the path into quantum, you can use Helium-3 as a fissionable material to generate electricity.
Is there enough of it to do that?
Currently, no. And which is why the United States, Russia, and China, and the European Union is looking to go to the moon, because it was found. The Russians had it. We found it in lunar samples, and it's very minute. You're going out on planet Earth, just in the air. There's Helium-3, Helium-4. You're going out 9 to 13 decimal points. You can't cost-effectively extract it.
Okay, we're 10 years away from that at least. How do we solve the problem today on Earth? And do you have the infrastructure set up in West Pecos?
By congressional edict, the only place that in the United States, there's two places, Tennessee Valley Authority and the Savannah River Plutonium Processing Facility. The world supply of Helium-3 currently comes from those two places in the U.S. There's one reactor in Canada, and then the Russians. And where the majority of ours comes from, it comes from the reprocessing of thermonuclear hydrogen weapons, of deuterium and tritium in weapons. Tritium has a half-life of 12.583 years. The value of it why is it so expensive? You do what is called cryogenic diffusion, and basically you cool something down, and where helium-3 and helium-4 turn into liquids is a difference of X number of degrees, and you can separate them at that point.
Can you transport it at that point as well?
You can either leave it in a liquid form or you can turn it into a gaseous state. In a value of a 1 liter bottle of helium is approximately $37. A 1 liter bottle of helium-3 is $2,750. In a 1 liter bottle of helium-3, you have 0.158 grams, so it's under a gram of helium-3. A 1 liter bottle of helium-4 is 28.7 grams. So they both will float. They both have unique properties. They're both stable. They're inert. They don't react with things. However, you can use magnetics to do different things, and cooling, ultra cooling, cryogenics.
Robert, you're a publicly traded company. You have a fiduciary duty to your shareholders to spend their money in a fashion that's thrifty and efficient and that eventually returns value to these investors. How are you doing that?
Not only by going after the helium, but by also in the Roswell area, because it's coming out of the ground in a very small amount, from 0.5 to 1.3%. We can strip that out. We built a plant that is state-of-the-art, which uses AI, and is basically cooling, pressure. Part of what we're doing with the pressure swing is that when you pass it through, it cools at a very specific size. And you're doing that repeatedly, and you're also using carbon filters and other types of membranes to separate everything out. The biggest thing is that when I originally started to design a plant to extract helium, how do you build things now with the thought of trying to be environmentally thoughtful for later? Not just now, but 40 years down the line, 20 years down the line. So my thought was, because these will be smaller pockets that you're going after in other places in the world, but if you put it into basically 5 40-foot modular units, you cut down. My original design was going to require 4 megawatts of power. Our current design runs on 320 kilowatts. So it's just a huge difference. You're using so much less energy to do it. And then for the energy that we do generate out there, we use nat gas, but when we built that and we had time to change up different aspects, we brought in the best technology for scrubbers so that for the emissions off the electrical generation, we're not just like barely over the line being set. Just here's the line and we're right there up against the edge of it with emissions. So far, we're down at 43 to 51%. And we went in to make sure that we were in compliance with the newest regulations that were going to come into play in 2025. You have fixed operating costs. Our average per kilowatt hour is less than a penny. It's 0.8 of 1 cent per kilowatt. That's our cost to generate electricity. Most places, if you're purchasing power to run a helium separation plant, you're talking 14 to 15 cents a kilowatt. If you're in Canada, you're 20, anywhere from 23.2 to 28.9, depending on where you're at in Canada. So to extract helium, you have to really think about long term. It's not just a flash in the pan so that you can say, wave the flag to your shareholder and say, look at us. And to make money long term makes it easier to maintain employees. I know how I was treated when I worked for somebody else, and there's good and there's bad. And there's a lot of times not feeling like you're being appreciated at all. It didn't matter what steps you went through. They just didn't give a rat's patooey about you. And when I hire people, I feel like I have a fiduciary responsibility, like you brought up to the shareholder. I have that same responsibility to the people I hired. That's the way I look at it. I don't want to just hire somebody. I don't want to just churn through people. Number one, you have to train. It's just a constant. It's not fun. When I had my own wells, and I used to have wells in Oklahoma and Kansas and drilled wells, I had lots of employees. I hated firing people. That was the ugliest days, is when people just wouldn't perform. There's too many drugs involved. Come on, folks, what can we do to help you get through this? And if they don't want to, I can't fix everything. I can't fix people. That's all I can do is try my best. But when I'm trying to work with people, when you and I have visited, I have a lot of fun discovering the science aspect and finding helium and natural gas and doing it in a responsible manner. To me, the greatest fun is when you see people. A friend of mine who was a federal court judge, he had somebody that was their first time ever being picked up on anything. There's nothing, absolutely clean. Had one night, really stupid. And yet, by the federal minimum sentencing guidelines, he was going to have to go to jail. And he had kids and a young family, so he got sentenced to the minimum amount of time, and then I gave him a job. And that man is now a vice president of helmet pain. And there's another gentleman, he's a neurosurgeon. You see those kind of people turn their lives around, you know that you've actually done something good.
I asked you about shareholder value. You responded with, wait a minute, what are we doing for the community? What are we doing for the employees of the company? So I'm going to come back at you with this. What are we going to do for New Mexico, for the people of Roswell, and for industry down there, by that this industry and ancillary industries related to it? If that's your philosophy.
I didn't dodge the question. I just got off because that's where my heart is. And for the people there, it provides, I can't employ everybody. That's not the way it's going to be. But the type of jobs that we would have, it's a mixture of different jobs within the company. And for just increasing when we do drill, I don't drill with the normal drilling techniques. We don't use all the chemicals. I like to say we use water as a mist, but we also use polydisaccharide.
Expand on that, because a lot of people don't understand drilling or the prospect of it, and they hear drill and they shy away.
What I found in Oklahoma, because I had my own rigs, my fingers show that I've oil patch trash. I've been torn up in the oil patch. But you try to learn to do things in a more responsible manner. So instead of using oil-based drill muds, use air and water, and as an additive to the water, because there's certain formations that if you just hit them with water, they want to cave in on you or crash in. And so you end up with a hole that's bigger. It just creates other issues. So to stay away from that, we use polydisaccharides. Most people know it as sugar. And we use pectin, which is a thickening agent, naturally occurring. You use pectin in jellies and jams. So what we use, basically, is all food grade. And then if you have to use a type of soap, we don't use, quote, Dawn dishwashing liquid, but it's called a surfactant. It's a type of soap, and it meets the highest standards. It's not going to get into anyone's system for you to do anything. If you had it pure and you had 2 tablespoons of it, it'd be the same thing as taking kaopectate. It would have the same effect. So we try to use everything that's as safe and environmentally responsible as we can. There's all kinds of rules out there as far as drilling and completing. I like to protect the aquifers, whether I'm in Arizona or Oklahoma or New Mexico. I've always wanted to protect the aquifers. That is the future. You have to protect them. And we choose to spend an extra 28 to 30% money drilling to put additional casing and cement it all the way to the surface, not halfway do little cement jobs here and there. We protect everything.
We had a change of administration this year. We have a new energy secretary, Chris Wright, comes from the resource sector. How has this affected your company directly, Desert Mountain Energy?
I have had an opportunity to speak with the majority of the cabinet positions, folks in that, and had people assigned that I am working with for specific aspects. In March, the president signed an executive order that dealt more with critical elements. There's two lists. There used to be two lists out: critical elements, critical minerals, and helium, helium-4, helium-3, and xenon, and noble gases. In the March executive order, it says critical elements. It now includes it, and we are working with specific departments on that. The company we had originally I had applied, and we have what's called a SAM number. It's a way to get paid the same day from the federal government, but you also just don't get to do work with them. We also have our NATO number. So obviously, that's where a number of things that we're working on will go down that pathway.
I understand some of them include a relationship with the Crown.
Yes, we signed an agreement. I am precluded by contract to say exactly who we signed with, but shall we say it's one of the largest land and mineral owners in the UK. And based on the area that we were given in Devon, it's fairly easy for someone to just quantify exactly where that is. I call it a real gift and a trust that we've been given to go drill for helium and hydrogen, specifically in those areas. It comes back to the way we chose to be environmentally sound going forward. It goes back to how you drill and set casing and cement it into place. It's not a requirement that you put cement all the way to the surface behind every string of casing. Nowhere in the state, anywhere in the U.S. or anywhere is it that a requirement. We choose to do it, and it adds cost. And in working with that, that helped us with the UK government to recognize that this company is really trying to not just give lip service and whitewash it or greenwash it, as some people might say. We're actually trying to do that. God gave me a brain, I'm supposed to use it. That's what my dad used to say. I used to hate that saying when he would pop off with, God gave you a brain, use it. I'm trying to be a good steward now and use it. And sometimes I'm better at it than others. When in business, a lot of people look at things when they don't go perfectly as being a mistake, whether it's willful or others. I don't look at it. If you're in business and you're not doing anything, having any errors, you're not doing anything. I don't consider it an error when things may not work out perfectly. A mistake is when you fail to learn from the error. That is when the mistake happens. That is a willfulness, failure to learn.
What I've learned about you from knowing you for, again, 5 years and from listening to you is that you're months out, you're years out with regard to mitigating risk. You're the king of mitigating risk. Problems will occur. And by that, Murphy's Law is something that you understand, that you respect, and you anticipate and you deal with in advance.
People look at it as, and I'm guilty of this too, there's sometimes you just get hit with so many things that are just, why? You've thought of this, and you have things come in from left field, usually from another human being. It's not normally planet Earth. Planet Earth is easy to, I can figure that out. The humanoids inhabiting planet Earth, that's where it gets interesting. And so how you try to figure and work your way through that so that people understand you're not purposely trying to destroy everything. You're trying to do things that make life better, provide better paying jobs for an assortment of people, not just one group of only the techno nerds that can run an AI center. You have to have everybody. At least in my mind, I always think, who else am I going to help with this? It's nice to have the personal kudos when they come, but what's really nice is like when I told you the story about the man who turned his life around. Now he's a VP of a company, a large company, or a surgeon. Those are some of the biggest successes in my life.
Let's talk about the Roswell AI campus and what you're doing down there. And in addition to that, the supply of natural gas, the energy you're going to be able to generate, I understand, could, if we had that amount of homes in New Mexico, generate electricity for 3.5 million homes. That's massive. So where's that all going to go since we don't have those residences here in the state?
This is one of the fun things that has come out of picking this up and that lease up and trying to go after helium and helium-3. It's now with the AI center, and we were asked to, initially they just wanted to buy the natural gas, and it gives us and it gives my shareholders more of a long-term. It's like where we don't go with all of it, or a possibility of going with natural gas, all of it that we produce, for as long as we choose to be there. Most of the time, the way natural gas contracts work, just a short version is, if you're a well owner and you're selling it, if it's the public, John Q. Public is paying, by the time it gets to his house, $8 per MCF of gas. What we're actually getting paid, like what we got paid last year, part of it was 36 cents. And somebody else in California where you live, you're paying $9.35 an MCF. Now you have pipelines in between, you have other stuff, and it has to be cleaned up to a tariff spec and all that. But we do all that with the plant we built in trying to set it up to strip out the helium content and the noble gases. We automatically clean the gas up. And we still get a deduct from the pipeline buyer purchaser. We're still getting hit for the gathering company in between. So how do you increase that? Because again, it gets back to my fiduciary responsibility for shareholders. You got to get paid more. So if the price of natural gas is at $2.15 or $2.16, whatever it is today, we would have a chance to be getting paid at least $2 out of that instead of 36 cents. That's a huge return for my shareholders. The other thing is what the AI Center has asked us to do is, because an AI center, the lights can't flicker at all. If you're down for 30 seconds for that AI center, if they do their total build out, if they're down for 30 seconds, that's $114 million. So how do you ensure, even though you can have natural gas coming through 2 different pipelines, there's actually 4 pipelines that cross our property, but there's just 2 of them that would be assigned to that, where there would be a line tap for them. What happens on average, every line goes down once a year for 3 to 4 days. So we've been asked to create an underground natural gas storage unit. Now, you can't just make a storage unit, just say, I want to go out across the valley here, and I'm going to put in a natural gas storage unit. I'm just going to drill a hole. And that's not the way it works. And if you want to do a withdrawal, a real fast withdrawal, you have to have more of a cavern. Now, you don't want to put that real close to the surface because you have to have the structural integrity. So it has to be buried. Normally, what has been the best is a salt cavern. Now, there's all kinds of caverns in New Mexico, and there's a lot of natural gas storage units that have been created in caverns, or where caverns have been created through salt dissolution. Looking in a 40-mile radius, because you have to be close enough, because you got to build a separate pipeline that could handle 724 million cubic feet of gas a day to run through an AI center, just to generate, through gas turbine, to generate electricity for that plant. I don't want to tear up the world to just put in another pipeline. So where do you go and you use existing right-of-ways? and you come down alongside that, so you're not tearing up a bunch of new stuff. And it can be easily revegetated or rehabbed. When you come into that, there's not enough salt. It's not underlying everywhere. You have to have very specific geologic conditions. Now we have an opportunity to go create a natural gas storage unit. And we happen to have enough salt to do this, to generate and create an underground storage for 5 days of natural gas supply.
In Roswell.
In north of Roswell, yes. And there's no where we'd be putting it. There's no homes out there by it. It's just ranching, which is important, but it's not like it's underneath a lake or a potable water source. It's buried deep, and you can safely do this. And that's one thing that when I was originally asked, I gave it less than 10% chance in my mind instantly. Until we really started looking at all the well logs, because we have 188 wells out there, and there's been more wells. There's been 240 wells drilled in that area. So you have a pretty good idea exactly what's there. So it'll still need to go in and drill a stratigraphic test specifically to take samples of that salt to ensure that it's not a maybe sort of, Ellis. It gets back to how I like to treat the environment responsibly. I want to make sure that when we build this, it's never going to have an issue. Because I guarantee you, by the time that AI center, 30 years, I doubt that'll be around 30 years from now. I'm not young like you. I want to make sure whatever we're building is going to be there. It's going to be safe.
What kind of opportunities exist for the state of New Mexico, the federal government, private entities, public entities, those techno nerds you referred to earlier, Silicon Valley, to join you as investment partners in DME and really grow a large complex, not just in New Mexico, but globally?
There's ways that they could, obviously being a public traded company, they can come in via private placement. But really what it is, it's in to help with regulatory and then to deal with that and people to understand that we're not a fly-by-night company and we're working with real people. Our goal is to build something that is lasting. And number one criteria is to do it responsibly, not just throw it out there. And the state and feds, there's opportunities, there's things that I really think where money could be spent for additional training for people for specific aspects of what we're doing for long term, also for specific infrastructure. I'm comfortable drilling. That's my forte. I love it. I love to watch samples come out of the ground and try to understand the earth. And then some of the other aspects with dealing with infrastructure, that's when things can get dicey. Or personal growth opportunities can really abound. This is unrealistic. This is realistic. And let's work together.
In California, we've got the Salton Sea and enough lithium probably to power 300 million cars. The infrastructure and transportation there is a huge issue. And it keeps people from investing like they may want to. It keeps it from being a real asset. We don't have those issues in New Mexico at all, do we? Not in Roswell.
It's not like that. We have what I would call responsible rules and regulations. And thus far, they have looked to try to, wait a minute, where can we assist you in this? So it's been pleasant to work with the state thus far.
As a journalist, I started covering the hydrogen sector about 10 or 15 years ago until I learned that it's basically useless in EVs because you really can't transport hydrogen because of the loss along the way. It's so small as a molecule. Literally, it'll go through glass. It'll go through most metal. It's a big part of desert mountain energy. How does that work?
One of the things that originally when I was looking at where helium is found, you normally, if you want to look for it, you will find hydrogen. Just from the breakdown, especially if it's a radiogenic generation of it, being the Earth's crust, again, getting back to uranium, thorium, lithium, beryllium, and if they're in close enough contact, how it's generated, and all the sister particles that are formed. Hydrogen is still very beyond just going through everything. the Hindenburg comes to mind. I wasn't alive then, but there is a safety issue. You can address, and I still believe that science long-term, somebody will really figure out a better way how to handle it. Somebody probably alive now which will come up with a way to help that issue. That being said, it's so small, it requires a lot of it to be able to do anything. Compressed natural gas in the back of a pickup is helpful for a car. Hydrogen, the entire back end of it's going to be full to go any distance. So how do you do this? One thing that has been successfully done, Pacific Northwest Labs has developed a type of hydrogen fuel cell. It's actually being used on a mine in South Africa on 400-ton ore trucks. It's still not cost effective. What is the most cost effective is if you can find hydrogen and you use the best fuel cells, you can use that to generate electricity. What we have found in Arizona and also in New Mexico, it's not just broadly all over for white hydrogen. You have hydrogen that is formed by water passing through iron deposits. And there's been tests done where they've actually drilled a number of horizontal wells, and you put an anode and a diode on either end, and you can generate hydrogen in the ground. Problem is, for every kilowatt of power comes out, requires 22.3 in. We have found a swath in New Mexico where there has been hydrogen production in addition to natural gas since the mid-70s. It's not very many wells because it's low BTU. So they were drilling, they found it, they got 15 to 20% or maybe 30% C1s or methane, and they had 40, 44%, 48 or 57% hydrogen. They just shoved it down the pipeline anyway. If you have a pipeline dedicated to hydrogen, it's really tricky. It's highly unstable. It breaks down all the metal. It makes everything brittle, goes to pieces very fast. In a well where you have H2S, which is hydrogen sulfide, which is poisonous, to those type of wells, they have to kill them to work on them. And all the casing that's used is a nickel steel, and you have to use specific types of cement. You can't use a regular type of cement that you would use in normal construction. You have to use specialty cement. Everything at the surface has to be nickel steel, and it has to be changed out on a regular basis. What we have found is through study, we found a swath that's about 1.5 miles wide, and it's about 42 miles long, where we think we can go after the hydrogen. We don't have to transport it hundreds of miles. We can put it in between and put fuel cells and run it through electric lines to come back to the Roswell Info Center. Either that, or in talking to the Excel and power company and county power, is how we would work with them to just put it back up into the power grid. So you get away from the transportation cost. Now, the other use for hydrogen would be to turn it into ammonia. Ammonia is 3 parts nitrogen, 1 part hydrogen. And that's used all the time. It's used in fields for fertilizer. So there's an instant market for it.
New Mexico is a big agricultural state. I imagine that you could really spur that with the development of this hydrogen project.
It's a natural resource. You can do it. So you can use it either to generate electricity right there with the newest power cells, or you can do something else. So it's a natural resource that's there to be used.
Robert, what are some of the problems you've come across with regard to horizontal drilling and hydrogen?
Ellis, when I started originally trying to look for helium, there's a lot of people who have done a lot of horizontal wells, and they've drilled, they tried to turn the curve, and they thought they're going to do this. And structurally, the wells downhole, the strata just doesn't have the structural integrity to turn the curve. It's called building a curve, to build that curve and make the turn. If you understand more of exactly where you have to go for helium, because helium is not going to be found in these broad, wide fields. It may be for a long ways across the field, but it's going to be in a pretty much a very narrow swath, or more like on a anticlinal feature where you actually have more like this, and you want to hit this. You don't want to hit this and go out here horizontally. Unlike where they drilled for and tried to work on hydrogen and generating hydrogen, where they're drilling horizontal wells, multiple horizontal interlocking wells in an iron-rich environment. They put an anode and a diode down. Basically, you put low voltage on either end, a lot of amperage, low voltage, and you have to have a lot of moisture, a specific type of fluid in it, and you use anions and dions to accomplish different things, to generate the hydrogen. And you're pumping this around. You don't do that for free. You're moving fluid. Anytime you're in the oil patch or anything underground, you're handling water. The last thing you want to do is handle water. It costs money. It's a highly regulated part of the industry. Over time, it requires more and more pressure to accomplish that same thing, because you actually start having the salts and all of the dissolved solids that are in water. It starts coming out. Kind of like old guys like us. There's a lot of people have hardening of the arteries. A little bit too much grease over time builds up inside. It thickens. Well, Mother Earth is a little more finicky. You can't just run in and run a stint all the time.
Robert, it's been a real pleasure to chat with you today. Thank you so much for joining me on the Ellis Martin Report.
I appreciate the opportunity. Thank you, Ellis.
The views expressed in this program are those of the guests and do not constitute financial advice or a solicitation to buy or sell any securities. Produced by Martin City Studios in association with Spirited USA LLC, providing award-winning quality media since 1988. Listeners should conduct their own due diligence and consult a licensed financial advisor before making investment decisions. Past performance is not indicative of future results. This broadcast is for informational and entertainment purposes only.